So dear students, now let me solve the most important question on friction. Okay, and this is a very interesting question and a very beautiful question to understand the whole thing that you have learned about friction. Okay, so let me see what is the problem. I have given the problem already here. Here this is an inclined surface, you can see, and a block of mass m is placed over here, and we have to find out the minimum force F, this F, and this force F is given at an angle beta with the inclined plane. Okay, so we have to find out this F such that the block has a tendency to move upward. So you have to give a force F to hold the object on the inclined plane, but we have to find out the minimum force that should be given such that the object will be just about to slip upward direction. At the same time, we will also try to find out the minimum force, this F, such that the block has a tendency to move downwards. So you can create these two possibilities by giving this force. First, if you just hold the object by using this force F, by giving this force F, if you just hold this object, then what will happen? The object has a tendency to move downwards. This object has a tendency to move downwards. But if you increase the force and increasing up to which such that the object will be tending to move upward direction. So by varying this force F, you can create these two kinds of limiting situation. One is when the object will be try to moving upward direction, and another case when the object will be trying to move downward direction. So the whole analysis, throughout the whole analysis, just what will be the different, the direction of frictional force, and obviously here we will take the limiting frictional force because this force is given in such a way that the object will be just tend to move. That is the limiting condition. Okay, so let me solve these two questions one by one. Okay, so let me take the first case first. Okay, the first question first. So this is my figure. So what is the forces acting on the object? Let me see first. So obviously I have already discussed this kind of situation that mg will be along this direction, and along this direction there will be a normal reaction, and you can easily find out by using simple geometry that if this angle is theta, so this will be what, mg cos theta, and along this direction obviously it will be mg sin theta, and obviously this theta is angle of repose here. Okay, here angle of repose is just denoted by theta, only theta, and this F can also be split into two components. One is F cos beta and another is F sin beta. And the next thing is what? The block has tendency to move upward, so the block will be just about to slip upward direction, so the frictional force will be obviously along downward direction, limiting frictional force. So now if we draw the free body diagram of this mass m, so what will be the free body diagram? So you can see downward direction, along this direction, this I like to take this as our y-axis and this is our x-axis. Okay, so along the inclined plane I like to choose x-axis, and perpendicular to this inclined plane this is y-axis. So what will happen? Along this direction we have mg cos theta, and along upward direction we have two forces, one is n, another is f sin beta. So along this direction we have n as well as f sin beta. Okay, and along x-axis, that is along the inclined plane, this direction we have two component, two forces, one is mg sin theta and another is fl, and along this direction we have only one force, that is f cos beta. Okay, and obviously the object is at equilibrium position, so there is no acceleration. So summation fx will be 0 as well as summation fy will be 0. So we have to use Newton's law again, that is summation fx is equal to 0, and this will imply that these two forces, that is mg sin theta plus fl, will be must be equal to f cos beta. So here we can write that mg sin theta plus fl is equal to f cos beta. And another thing, if we use summation fy is equal to 0, then what we will get? N plus f sin beta is equal to mg cos beta. So n plus f sin beta is equal to mg cos theta. So from here we can find out n. Okay, so n will be what? mg cos theta minus f sin beta. So if this is our equation 1, 2, and this can be taken as equation 1. Okay, and we have to substitute this value here, because fl is what? Mu into n. Okay, so instead of mu s, I like to choose here mu. Okay, only mu. So this is just static friction, coefficient of friction. So I can use this mu as static coefficient of friction because there is no motion. Okay, so obviously mu will represent the only static coefficient of friction. So you can use here that mg sin theta plus mu n is equal to f cos beta, and you can substitute the value of n here. Okay, so what you will get? You will get just mg sin theta plus mu, instead of n we can write mg cos theta minus f sin beta is equal to this f cos beta, mu n and cos beta. Okay, so we have to find out f from this equation. We have to find out first f, then we will see what is the minimum value of f. Okay, so let me first find out what is the value of f. So from this equation we can write over here that mg sin theta, okay, plus mu mg cos theta plus mu mg cos theta plus minus mu f sin beta. Okay, minus mu f sin beta is equal to f cos beta, is equal to f cos beta. So we can write from here that mg sin theta plus mu mg cos theta equal to, we can take common f from these two, so f into, we can write over here that this will be mu sin beta plus cos beta. So from here we can easily write down f. So f will be finally mg sin theta, okay, mg sin theta plus mu mg cos theta divided by mu sin beta plus cos beta. So this will be our f. Okay, now we can simplify this result again by using our well known equation, the relation between mu and lambda. You know, mu is equal to tan lambda. We can involve lambda here. Okay, and here lambda is the angle of friction. Lambda is what? We know lambda is equal to angle of friction. Okay, so lambda is equal to angle of friction, so we have to use lambda here. So mu is equal to, we can substitute here mu is equal to tan lambda. Okay, just for our simplification of calculation. Okay, so here you can see, if we substitute here, then mg sin theta plus, you will get tan lambda mg cos theta divided by tan lambda sin beta plus cos beta, okay, plus cos beta. And now if we write this tan lambda as sin lambda divided by cos lambda, you can write here tan lambda is equal to sin lambda divided by cos lambda. Here also sin lambda divided by cos lambda. Okay, so sin lambda by cos lambda, here also sin lambda by cos lambda. Okay, so in the numerator and denominator both side will get cos lambda and denominator. Okay, so let me give you the calculation, detailed calculation, no problem. So mg sin theta plus, you can see here that sin lambda by cos lambda into mg cos theta divided by, you can write here also that sin lambda by cos lambda into sin beta plus cos beta. Okay, so now we can write in this side. Okay, let me write now in this side. So this is a big calculation, you have to make it, but the problem is very interesting and you will get the final conclusion after this calculation. And I am using this calculation just to avoid the differentiation. So you can find the minimum value by using the differentiating, okay, but I don't want to use this kind of thing. You can easily find out the minimum force only by using a simple trigonometric trick. Okay, so what we can write from here actually, now if we want to write f, so f will be just, you can see here we can use cos lambda, okay, on this side. So mg into cos lambda sin theta, you know, mg into cos lambda sin theta plus sin lambda mg cos theta. So mg into sin lambda cos theta. Similarly, we will get here also cos lambda, and it will be just sin lambda sin beta plus cos lambda cos beta. So you can find this cos lambda will be cancelled out, so we will get finally this mg can be common, take common. So mg into, you can get from here cos lambda sin theta, okay, plus sin lambda cos theta divided by sin lambda sin beta, or you can say here first cos lambda cos beta and plus sin lambda sin theta, sin lambda sin beta. Okay, so now this is cos lambda sin theta plus sin lambda cos theta is nothing but sin lambda plus theta, sin a plus b. This is the formula, just trigonometric formula of sin a plus b. So you can write here mg into sin lambda plus theta divided by, this is nothing but cos lambda cos beta plus sin lambda sin beta. This is cos a minus b, so this is just cos lambda minus beta. So cos a minus b is cos a cos b plus sin a sin b. Okay, so this is final expression of f. So this is the final expression of f. In terms of lambda, I have involved one more variable, lambda, okay, which I have not mentioned over here in the problem, but sometimes in problems they mention lambda. Okay, there is the angle of friction, so you have to involve lambda in the calculation. Okay, so now you can get the value of f, the minimum value of f from this calculation. You can also find out the minimum value of f from this equation by differentiating this equation with respect to beta. Okay, by differentiating this equation you can get but I don't want to get from this equation by differentiating, because this is a very easy calculation. Just using the trigonometric formula you can get this equation, and you can easily say that this f will be minimum when this cos of lambda minus beta will be maximum. So this is very easy to say that f will be, because you know here all things are constant. This theta is constant. Okay, theta is constant. The only variable thing is that this beta. Okay, so at what angle you can give the force at what angle with the inclined plane, such that you can achieve the minimum force. So the variable is here, you can see. So if cos lambda minus beta is maximum, then what will happen? F will be minimum. So we can easily write from here. Okay, we can easily write that from here. Okay, that f will be, I can write f will be simple, f will be f minimum when you can see from here that cos lambda minus beta is equal to 1, because the maximum value of cos theta is 1. So what it means? It means that lambda minus beta is equal to 0, and that means lambda is equal to beta. So if this angle beta is equal to the angle of friction, then you will achieve the minimum value of force F. And in that situation you have the minimum force will be just mg sine lambda plus theta. This will be your final result of minimum force, and this is just the condition. This is the condition to get the minimum force. Now in the next calculation, the next problem, I am giving you a homework for this problem. You can achieve the same calculation by the same method that I have used, but only difference will be in this frictional force, because you know what will happen, this frictional force will be now changed for the problem 2. Let me analyze this thing. The analysis is so beautiful. Instead of calculation, you can get this calculation easily, but the analysis is so important here. So please see the analysis. Okay, analysis part. So let me give you the analysis part. So here what will happen, if the object is tending to move downwards, so you just hold by this force the object on this inclined plane. So what will happen, the object will tend to move downward direction, so the limiting frictional force will be now along this direction. Okay, so now if you make the whole calculation, then you will get the same result, but the only difference is you will get cos of lambda, instead of cos of lambda minus beta, you will get cos of lambda plus beta. You can do the calculation, and I am giving you the result. You will get the condition for minimum will be cos of lambda plus beta is equal to 1, and the minimum force will be lambda minus theta. I think this will come mg sine lambda minus theta in the denominator. Okay, so cos of lambda plus beta is equal to 1. This will be the condition if you make the calculation in the same way that I have discussed earlier. And from here, a very interesting thing you will get, that lambda plus beta is equal to 0, so lambda will be minus beta. Now you will get lambda is equal to minus beta. Can you tell me what is the significance of this negative sign here? What this negative sign actually means? Because now your lambda will be in opposite side. Let me see. This is very interesting thing. What is lambda? What is lambda? Please remind. What is lambda? If this is just a horizontal surface, then one force is normal reaction and another force is limiting frictional force. So if limiting frictional force is this and normal reaction is this, then this will be your resultant force and lambda will be this, isn't it? Lambda is the angle between the net contact force and the normal reaction. And when this will happen, if the applied force is along this direction. So if applied force is along this direction, then the limiting frictional force will be in this direction, so R will be in this direction, and in that case lambda will be here. But if you change the direction of the applied force, then what will happen? If you give the applied force along this direction, then what will happen? Your limiting frictional force will be in opposite direction. It will reverse. And now in this situation, this will be normal direction, and this will be your net contact force R. So why your lambda will be in this opposite direction, opposite side. So if we will tell this as positive lambda, then we have to tell this as negative, because if this is a clockwise direction, then you can see, if this is anti-clockwise direction, then you can see this is clockwise direction. So if you take one positive, you have to take another negative. That is happening here, because initially you have the frictional force along this direction. So if you take, if you have the FL in this direction, then the net contact force will be along this direction, so this will be your lambda. But now what is happening? FL is in this side, so now the net contact force will be along this direction, so lambda is here, and that's why you will get this negative sign. Okay, the rest of the part is same, just same. So please don't think about this negative sign does not exist here, lambda cannot be negative, etc., etc., that this is just the absurd result. No, this is a very good result, and there is a significance of this negative number, this negative sign. Okay, so don't worry, please do the calculation and make it sure that this will be your result. Okay, thank you.